recently, but it has not come because there is a compromise that has happened. Yep. So let's come to the fundamentals of security. So seeing all these examples, right? So security fundamentals are basically the confidentiality, integrity, availability, and non-repudiation. And in a fancy world, everyone called as a CIA tried. They don't give much importance to the non-repudiation, but that is as important as something to find there is a breach that has happened, basically. So confidentiality, like what is confidentiality? It's more like a person basically confidentiality that is nothing but you are authenticating yourself to the system. Basically and only authorized persons should have access to the software or data it produces, basically. So that means confidentiality means I have a data, it's confidential, but confidentiality means who should have access to that confidential information. You should set some authentications, authorizations. You have some encryption in place that the data is uh, uh, data is encrypted and protected. So these are all something nothing but confidentiality. And integrity, so basically the integrity is all data produced by the system cannot be modified without proof of modification, basically. And and then the availability is nothing but how well, like there should not be any denial of service. So how well is your availability, like if you are getting thousands of requests where you have a limit for 100 requests for a server to accept, that means 1,000 requests are coming, so you don't have, so that leads to a server crash and it denies every request. So it's nothing but denial of service. So that comes in tax. So these are the threats with respect to these fundamentals. So non-repudiation means you are doing something, but I did something to your system, but I deny it that I have done it because you don't have anything. So say suppose you don't have logging in place. So I have sent some malicious information to your server, but you don't have anywhere that logs that I have sent this information, and I can deny it. So I sent it, but I can deny it. That's nothing but the non-repudiation, basically. So confidentiality is about protecting authentication, authorization, and protecting your data. How confidentiality lies in protecting your data, and the mitigation controls for the confidentiality is authentication, like proving who you are, authorization once you are authenticated, whether I have access for it or not, and data encryption. Basically encryption is nothing but converting your plain data into an cipher data. The cipher data is nothing but a random organized data that no one can even read it, basically. And next is integrity. So integrity is basically prove that I'm sending one message to you, and if some attacker tries to steal that, he's sniffing the network between you and me. So that is called as a man in the middle attack. So he sees I have sent like hello, how are you, then he sniffs that request, and then he said like I need some money, can you please send it, and then he sends to the receiver. So receiver thinks that I'm sending that message, but he has brute force, so the integrity is lost. So integrity can be established by having digital signature, hashing, message authentication codes. So basically how it generally does is, so I'm sending hi, how are you, then I will hash the data, and then hash is nothing but is a one way. Once you hash some data, you cannot dehash or rehash or something. There's nothing called a hash. That's the reason, unless until you know the actual word, you cannot you cannot know the hashed comparison, basically. So you hash it, and on that hash you do a digital signature that no one can see. So the digital signature means like I proved myself that I have sent this information, this is my digital signature. If an attacker tries to change the actual information, then the digital signature will fail and the hashing would fail, and the recipient will see that so it's all interlinked, basically. Like you have a message, you have a digital hash, and you have I mean basically the message authentication code, and you have a digital signature. So if an attacker so the chain is like, if hi, how are you, it will be hashed, that will be a message authentication code, and you do a digital signature, that means encryption of a hash is called a digital signature. So you have the complete packet will be going to the recipient. The attacker changes the text, but he cannot change the hash because he don't know the hash key. and he cannot know the digital signature. He don't know the private keys for it. So it will be at the recipient end during the initial TLS handshake. They take the keys, and then you know, he will change. Like he will say that I need money with a M- Mac of hi, how are you, with a digital signature of hi, how are you. But there on the recipient end sees his digital signatures, his Macs are not matching the actual information, and it will tell him that your network is, compromised, or somewhere someone is trying to steal your information. So please don't trust. So that way the connection gets disconnected. So that's about integrity basically. So the availability is basically how well your systems are available. In here it comes many concepts called as load balancing. you know you have hundreds and thousands of lakhs of millions of requests, then you need a load balancer and a different systems in place so that you can route. Like, say suppose I have 1,000 requests, but my server is capable of handling only 300. So you have four servers in place. There should be a load balancer in place to distribute the traffic to each. And you should protect your load balancer as well as these servers as well. So this is all comes under the availability. So if you get like a 1,200 or a 5,000 requests at a time, then you need to have some throttling. So basically you see a captcha somewhere on your web pages when you log in. Even for the Zoom, you need to verify, authenticate for the bots, because I can write some script to send like a 1 million request to your website. Basically it just takes 5 minutes time for me to write some script and do a denial of service. But you need to have a capture or a quota or a throttling in place in such a way that if it crosses um, you know uh, 100 or 500 requests, you give this captcha so that user has to. So unless until a user comes in picture, this will not proceed forward, and his request would be denied. So non-repudiation, as I already mentioned, that you need to prove that you have sent the message to themselves. So a user can deny that I have sent, he did an action basically. So that means you need to have a logging, monitoring, auditing in place basically for this. So these are the fundamentals of security. And also there are like design principles. Like considering these fundamentals, you have some design principles in security basically. So if you follow these design principles in any aspect, then you are well protected from, I mean, you are not susceptible for any breaches. You are well safeguarded. And let's understand what is design principles, and let's give a quick comparison with the year games. So first one is limit the information disclosure. So you should always have some, you should always not expose your sensitive data to the outer world. So you should protect, like you need to, you need to limit the amount of information that can go. So you need to have a data classification in place that, I have some company revenue that should be a restricted data only in the organization. Top level people can only see. So that is like you're not disclosing to everyone. So that's data classification. So you need to have data tags for every thing in your organization. Say suppose asset information. So I have all the asset IDs and MAC IDs and everything with me. So that should be only to the admins, not even to the top level management, not even to the every employee. So that is the limit of, information disclosure. It should be very limit basically. And then limit the attack surface. So that means you should not provide a chance to have a more attack surface. That means you should not have unnecessary servers, unnecessary controls into your. You need to always define the scope. Like, say suppose I have an application with me. Basically it helps to read content, like to help people to read the content, but I am also provisioning to post something, and also I'm provisioning to edit something in that. So he has got a lot of attack surface, right? Like he can do anything with it. He can modify the content, he can update anything. So you should always limit the attack surface by having proper. So attack surface, it's not about provisioning through application, it is also through network rules. Say suppose I have a so every organization, they have this firewalls in place. Okay, so that means in my organization, I'm connected to my corporate network, VPNs, basically virtual private networks of my organization. I cannot type and open some OSI guide or something which is an attacker site. I cannot open some. So there is in the outer world, you have a classification for each URL. Like if you have a URL like facebook.com, that goes to a category of social engineering kind of things, and that has, like, they do this evaluation, they have this metrics that every URL with a corresponding risk and corresponding controls in place, whether you are allowed or not. So if you have firewall rules in place, you cannot allow them. So that's like you're limiting what you need to access, right? So that's limiting the attack surface. And least privileged access, so that means in the you should have a least privilege access. The authorization should be very minimal and very strict across the organization. That means if you see the first colonial pipeline, so if there is a least privilege access there, user privilege access there, then an employee, even though he downloads, he cannot add some new services in the colonial pipeline network, because he doesn't have that privilege itself. So he needs to attack some higher level person. That means he would already have some controls in place, he would already have some knowledge in place, there would be already a monitoring he does every day. So this breach could not have happened even with the EA gains, even with the solar winds and everything. So you should always have this least privilege access. And the defense in depth, that means you should have defense controls everywhere basically. Like that means uh, so every layer. So for example, if you take a web application, so there are like different layers in it. Like you have a web server, you have a web server, nothing but that hosts your application, the front end code. You have a business service layer, you have a database layer. So you need to have, so if you're doing input validation, say suppose I'm entering some junk information, you need to validate the data. You need to validate that data. That input validation has to be done at your web application layer end, at a business layer end, and also as a database layer end. So if you're not doing that, for example, you can do all types of cross-site scriptings, basically on the XSS attacks on your application end. If you're not having on the business layer end, it can lead to an injection attacks in the surface. Basically, if you are not having those controls in the SQL server side, then it can lead to any SQL injection attack that is possible to get steal any information, or you can pollute your database, you can do anything. So you need to have this defense in depth everywhere. So you cannot take like I have say you cannot say that I have my input validation on my application, and that doesn't mean that you should not do at application layer, I mean business layer, at the database layer. You need to validate the information at every layer. Who knows, someone tries to breach your service, that means you get some data. So the attacker breached your business service, that means it happens, right? Like then your service is compromised. So you need to have these controls everywhere. That means the difference in that. Secure defaults, yeah. This is one of the interesting that people try to. So there is, for every software and every cloud service or anything, they have some default security considerations. So people, to take advantage, to make ease of the process, they try to tamper the defaults, like they try to change it. Say suppose a SQL server in a cloud, Azure or AWS cloud, it has a place that you need to whitelist your network from which it can connect to, basically. So that means I can only request. So if I want to access the SQL server, I need to go into Azure admin and provide my IP, that this is my IP. Please grant me permission to access from my local machine. Then if you do that, then only you will be able to establish a connection between your SQL server. But if you switch off that feature itself, then anyone can connect to the database anywhere. So it's like you're tampering with the defaults, basically. So you should always have a secure defaults practice. So if 100 employees wants in an organization to access a SQL account, then you need to give a range of IPs that needs to be allowed, but you should never turn off that feature itself. So that's about the secure default. So these are the different security design principles. So if you take these principles and take our mapping with the EA games breach or something, if you follow these principles, that attack would not happen. If you follow these principles, that attack with solar winds or with the colonial pipeline would never have happened. It's just a straight away comparison, right? You know that attack. So the colonial pipeline, so user privilege is not there. So it has happened. They have the wider attack surface because they don't have any controls, and they have information disclosure. That means they don't have any this data classifications. Everything is a plain text. So even connection strings are part of the code. So he got access to the code and he has seen which servers he can connect to with these credentials, and then information disclosure has happened. And they don't. I mean, attack surface. Basically, they don't have it, right? They don't have any controls in place to detect it. So if they have considered these design principles, this breach would never happen. Basically, at least if it would have happened, it would have intimated at the initial stage itself, and this much compromise would never has happened. Okay, so let's see the AWS security. So this is about so we as of now we have learned cl- uh, secure cyber, what is cyber security, security practices, uh, breaches due to lack of security, and so security fundamentals, basically the CIA tried, and then design principles. Now we want to see about AWS security as part of our section session. um, so AWS, before coming to the AWS security, we should say about the cloud is nothing but all your infrastructure as services, everything like you have like infrastructure as service, software as service, platform as service. But so there are multiple cloud providers in the outer world. There's AWS by Amazon, Azure by Microsoft, GCP by Google. So you have multiple cloud platforms. All they do is you need not take about you need not think about hardware. We will do on your behalf. You just consider your part of your code and um, deploy on our cloud services. We will take rest of it, but it's a shared responsibility model anyways. So that means AWS can assure you, or a cloud service can assure you that I will protect my data center. So when you think of cloud, it's nothing but they have the data centers their own at some physical locations across the globe, and they give you a front end interface to do all your configurations and set up your virtual environment spaces for yourself for using the front end, and that gets created in the backend on the data centers basically. So for that, the security comes from the physical security persons on the data centers, the power connections, the data availabilities. I mean, basically the security controls for accessing the data centers, and the network, the perimeter networks that gives a connection to the seamless connection to the front end portal and to the user that you can configure services. So it comes like every aspect basically. But when you come to the AWS security, um, so when you come to the cloud security, there are like five things in place. Like one is identify and detective controls, infrastructure security, and data protection and incident response, basically. So these all five different aspects will be the top level in considering these security controls. So if you see the AWS security, you have a AWS global infrastructure. That means the data centers and global accelerators that provides your seamless connections. And you have a data center security. That means your physical security and as well as the software security, like data encryptions and the access organization and the proper alerting and monitoring systems. And the next is compliance and governance. So AWS are all certified with CIS, NIST, ISO, like you have HIPAA, PCII. So PII. So they are compliant with all the security standards to use their services basically, and they have this DDoS mitigations in place. DDoS is nothing but distributed denial of service. That means they can smartly identify if you write a bot to send thousands or millions of requests to your service that is hosted on the cloud. They have a mechanism in a place to identify how they do the frequency analysis of the incoming request from a specific IP, and then they block it if this is not listed, and they add it to your database, saying that this is one of the malicious requests with this URL and this thing. So in future, in the first request itself, they block that. So they have a super power DDoS mitigations in place. And security in the cloud is basically application. So what if your application is vulnerable? What if your application doesn't have any controls itself? That means so it's a shared responsibility model, I said, right? So that is security in the cloud. Your application should have much more security controls, at least the OWASP top 10 security controls in place: the authentication, authorization, validations, communication security, exception handling, everything. So the entry points on AWS basically does it means that the endpoint protections and you know the network load balancers and elastic load balancers, application load balancers to seamlessly enable the connection between your services, and identity and access management. That's one of the big um, preliminary uh, that is one of the basic thing. It protects your complete services in your cloud. Basically, you need to identity access management is nothing but user provisioning, basically, and then detective controls. Basically, if there is some breach that is happening, you need to detect. So if there is an executed, you create a virtual machine on the cloud, and some attacker tries to enter into the virtual machine and try to install some exe. So these detective controls will monitor and then give an alert to the admin saying that there is some ad hoc process is running, please go and turn it off or do something. So infrastructure protection, yes, as said, like the firewalls and perimeter protection and multi-factor authentications, like these all comes under the infrastructure protection. The data protection is nothing but protecting your data. That means the data encryptions, the disk level encryptions, and who has access to those backups. Basically, the data backups and recoveries, everything comes under the data protection. Incident response are nothing but when there is when there is uh, when there is an incident that has happened because of some weaknesses in your machine, then how well you can identify and you can trace that incident and then get back to the normal process. So that's more about the incident response. And well architected tool is basically it's a tool that is provided by AWS to identify the compliances in the machine that comes with the AWS trusted advisor that gives. So you have 1,000 AWS accounts in your corporate or in an organization. So you can use this well architected tool to basically see how many accounts are compliant, how many have weaknesses, how doesn't have something. So in a broader perspective, you can see these all security controls. You can consolidate it into 5 types. One is identify, detective control, infrastructure security, data protection, and incident response. So identity is basically defining and enforcing and user permissions on the AWS services, basically, and that you have like AWS organizations, Cognito, directory service. There are lots more in that. And detective controls is nothing but gaining the visibility that you need to spot the issue before they impact the business, and it improves your security posture and reduces the risk profile for your environment. And that has you have a lot of features on AWS like Cloud Trail, Config, CloudWatch, Guard Duty, VPS Flow Logs, and all. And infrastructure security is nothing but reducing the attack surface area to manage and increase the privacy, basically, and control the overall infrastructures on the AWS. And that has to do with WAF, web application firewall, firewall manager, inspectors, virtual private clouds, system managers, and shields. And the data protection is nothing but server side encryptions, Amazon Macy, basically that is an automated service with AI and ML that reads your data and identify the sensitive fields and does an encryption automatically. And a cloud secure hardware security module is a specific disk on a data center is provided to you that no, it's not a shared disk. It's only for your organization. And then that's so costly anyways. It depends on the requirements of the enterprise. And incident response, as mentioned, how well you get back to your normal position when there is an incident, and how do you react. So how soon you actually react. So for that you have serverless functions called as Lambda and some config rules in place. So this is about an introduction to small AWS security. And I think you have any questions, we can drop. You can ask for the chat. Thank you.